In this lesson, you're going to learn how to do prime factorization of any number. Knowing how to find the prime factorization will be helpful throughout this math class. You should have learned how to find the prime factorization for a number in a previous math class, but I'm going to show you a method that I prefer that you use. You first need to know what the prime numbers are. A prime number is a number that is divisible by 1 and itself. 1 is neither prime nor composite. 2 is prime because it is divisible by 1 and itself, 2. Its only factors are 1 times 2. 3 is a prime number because its factors are 1 and 3. 4 is not prime. Its factors are 1 and 4 and 2 times 2. 4 is a composite number. 5 is prime. Its factors are 1 and 5. 6 is a composite number. Its factors are 1 and 6 and 2 and 3. So you see the list of prime numbers we have here. It is most common to use the prime factors 2, 3, 5, 7, 11. So it's good to know that list of prime numbers. Of course, there are more, but 2, 3, 5, 7, 11 are the most common that you'll be using. So let's start with our first example. We're going to find the prime factorization of 52. We're going to start by dividing your number by a prime number. Choose any prime number that will go in to your number. I tend to start with the smallest prime. Notice that I have set up my division upside down. If you are uncomfortable with that, feel free to do your division as you're used to. Just know you may run out of space because you never know how many times you'll need to divide. So that's why I set mine up upside down. 2 goes into 52 26 times. So we'll continue to divide by a prime until we get a quotient or an answer of 1. So now we're going to pick a prime that will go into 26. 26 is even, so I'm going to stick with 2. Again, if you can choose any prime number that will divide evenly into that number. So 2 goes into 26 13 times. 13 is no longer even, so we're not able to divide by 2. But notice, through our list of primes, 13 is a prime number, so of course it can be divided into itself. You will stop when you get a quotient or an answer equaling 1. So our prime factorization of 52 is 2 times 2 times 13. When you multiply this together, you could check in your calculator, multiplying 2 times 2 times 13, it should equal 52. And also notice that all of these numbers are prime numbers. So we've done the prime factorization of 52 equaling 2 times 2 times 13. Let's look at our next example, number 2. We're going to find the prime factorization of 84. So we're going to, again, start with dividing by a prime number. You can choose any prime number that will divide evenly into that number. Because 84 is even, again, I'm going to start with 2. 2 goes into 84 42 times. 42 is even, so again, I'm going to choose to divide by 2. 2 goes into 42 21 times. 21 is no longer even. Therefore, we're going to need to pick a different prime. We can no longer divide by 2. So let's see if 3 works. The divisibility rule for 3 is that if the sum of the digits is divisible by 3, then that number is divisible by 3. So 2 plus 1 is 3. So the sum of the digits is 3, and that is divisible by 3. So that means this number, 21, can be divided by 3. 3 goes into 21 7 times. 7 is not prime, so we cannot divide by 2. The sum of the digits, well, that is not divisible by 3. We cannot divide by 5 because 7 would have to end in a 5 or a 0 to be divisible by 5. But notice 7 is a prime number, so of course we can divide by 7 for our prime factorization, and we get a quotient of 1. So that's when you know you can stop. You have to get to that 1 in order to complete your prime factorization. So our prime factors are 2 times 2 times 3 times 7. We could check this in our calculator. Multiplying these numbers back together, it should equal 84. Notice also all of our numbers are prime numbers for our prime factorization. Pause the video at this time to try the next two on your own. Let's check your work for number 3. We're going to find the prime factorization of 45. So we're going to start by dividing by a prime number. 45 is not even, so we cannot divide by 2. 45 is divisible by 3 because the sum of the digits, 4 plus 5 is 9. So the sum of the digits is divisible by 3. 4 plus 5 is 9, and 9 is divisible by 3. So that means this number is divisible by 3. 3 goes into 45 15 times. 15 is divisible by 3 because, again, the sum of the digits, 1 plus 5 is 6, and 6 is divisible by 3, so that means this number is divisible by 3. 3 goes into 15 5 times. Now we'll have to pick a new prime number. We can no longer divide by 3, but we can divide by 5. Of course, 5 can go into itself one time. So the prime factorization is 3 times 3 times 5. Let's look at our last example, number 4. We're going to find the prime factorization of 570. So start by dividing by a prime number. I tend to start with the smallest, but feel free to choose any prime number that will go into 570. Because 570 is even, I'm going to divide by 2. So 570 divided by 2. 2 goes into 5 2 times. We'll subtract, bring down to 7. 2 into 16, because it won't go 17 evenly, so 2 into 16 is 8. 2 times 8 is 16. Use this one and bring that down. So 2 into 10 is 5. There we go. So 2 into 570 is 285. $285 is not even, so we'll have to choose a new prime. Let's try the sum of the digits. 2 plus 8 is 10, and 10 plus 5 is 15. So that is divisible by 3. 2 plus 8 is 10, and 10 plus 5 is 15, and 15 is divisible by 3, so that means this number will be divisible by 3. So let's do that division in a calculator here. We have 285 divided by 3 is 95. So 95 is not even, so we cannot divide by 2. Sum of the digits, 9 plus 5 is 14. And 14 is not divisible by 3, so we're going to have to go on to our next prime and try 5. 5 should work because it ends at a 5 or 0. That's the divisibility rule for 5. So because this ends at a 5, 95 will be divisible by 5. So 95 divided by 5 is 19. And then notice in our list of primes, 19 is a prime number. So we can divide by 19 to get our quotient, or our answer of 1. So our prime factorization will be 2 times 3 times 5 times 19. And of course, as always, we could check that by multiplying them back together in our calculator, noticing it does equal 570. And always verify that each of your factors are actually prime numbers in your prime number list.